Just a quick check, we're at the friction system now. Okay, how to calculate the friction stresses? I would most probably think about is actually a coefficient of stress. But nonetheless, just a warning, I may not explain things in a good way, so please be careful. Alright, so open up your eyes and be careful of my rubbish coming up next. So anyway, try my best to explain. So the friction is defined as the resistance relative to sliding between two surfaces in contact under normal load. Alright, so the normal load, I would believe, is the forces acting downwards. Alright, so although you may be, for example, this is the surface, this is the object, a normal load is this load acting onto the floor. Nonetheless, there will be a certain direction moving here. Alright, but the normal load is talking about the load that is normal to that is normal. Alright, so I actually searched for it. Alright, and you can see the W is actually the normal forces. Alright, and the equation for friction is actually this one. Okay, I'll not go into details. So this is actually a static friction to a certain extent. So I don't know whether is it applicable for our case, but never mind. So how this surface, how do you calculate the friction then? Alright, so we have to first get this area. Alright, these are all the asperities area. The asperities are just these mountains. Alright, so the area where the asperities between two surfaces contact each other, there will be a certain area surface. Alright, so the area at this point, all this you add it up all together. Alright, between all the surfaces, and you call that the true contact areas. Alright, so when you add everything together, this is the total contact area. Alright, hopefully this is pretty clear. So the maximum load before yielding is this one. Okay, so your load W, or your normal forces, is actually force over area. Okay, so for example, the force you change to W, alright, and then you bring this area upwards. Alright, you'll have area times stress. Okay, because force over area is equals to stress, right? So the area that we have found out is the contact areas between all of them. So the area is this one. Alright, and the stresses, alright, is before yielding. Yielding means that it's permanently deforming of your materials. So therefore, instead of stresses, we can write as yield stresses to a more defined one. Alright, and therefore this will give you the amount of normal force, the maximum load that you can give before yielding starts to occur. Alright, and why do we want to know the maximum load? Alright, because if you have two surfaces, this is one surface, this is another surface. If you try to drag it along this particular surface, this interface, alright, the yielding may occur, right? So after, if you have certain load that is larger than this one, for example, if this is 30k or 30,000, if the 30 kilonewton, sorry, yeah. So if the forces is 40 kilonewton, alright, then this most probably will actually cause the friction to occur. Alright, and therefore you will scrape away some part of the material away. So the harder one will scrape away the softer one, or either way. Alright, so be careful of that. And not what am I talking about anyway. So at least you get a meaning of how this equation comes about, that is related to what you have learned. Alright, so over here this picture is showing you a micro welding. Alright, why is it a micro welding? It's talking about different different metals. Okay, so what it means is that if you have this asperities, they touch each other. Alright, and when you start to move, alright, there will be a friction that is occur, certain forces, certain stress. So this amount of stress will actually permanently yielding, or you actually deform the things. So they will generate a heat that will cause certain welding that occurs between them. Alright, and therefore this is the welding that is trying to say over here. Okay, so plastics and elastic deformations are developed along all this asperities, forming this type of micro welds. Alright, so the form of deformations actually causes micro welds to happen. Alright, so you just need to take note of that. And the problem with this is that if you have more more of this yielding that occurs, you will actually form more junctions or accelerator. So instead of this one only here, when you slide, alright, it may actually cause certain form of more accelerators coming out. Maybe something like that. Okay. So maybe this part over here will actually cause more surface area contact. So if the larger the area, what do you see? Or the larger the area, this means that because the yield strength is always the same. Alright, so because it's the material property right? So if the area increase, then this means that the force in order to deform the material decrease. Alright, so I repeat again. So I zoom in. So this is the material, alright, the material's properties. Alright. So for example, if in order to start yielding, you requires 30,000 kilonewton. Alright, I mean 30,000 Newton. Okay. So if your area increase, alright, then definitely, so initially maybe this is 10 kilonewton, maybe not some 10,000. Okay, then maybe, sorry, the stress is 10,000 Pascal or whatever. Alright, then area is maybe 3 meter square or whatever. I don't know what's the unit but anyway, so this thing over here, if the area increase, as you can see, these forces will be 40 kilonewton. So if you increase the area, the contact area, alright, you are most likely causing the things to deform, alright, and you are causing more friction to occur. Alright, hopefully you are clear about that. So the lesser contact area we have, the better it is. Alright, and therefore you wouldn't want anything you don't want micro welds to happen. Or you try to actually reduce the micro welds so that this will cause lesser accelerators contact area. Alright, and therefore you necessarily reduce our amount of forces that will cause yielding that occur. Hopefully this is pretty clear as an introduction. It's actually quite heavy of a chapter, alright, although it's not necessarily important, but I think it's good that you would check it out this in the future. Alright, so this is the first part of this video. I'll continue with the Boldin and the Tabor theory and the rest later on in the next video. Right, so this is generally an introduction video where hopefully this explains quite well of the meaning behind all these equations. Alright, so after that then we can explain things in a more detailed way later. So see you there.